Hi, today I will talk about variant interpretation for HR gene in patient with Atrichia with papules. First, we'll talk about the Atrichia with papules, which we call it APL. This is very rare health condition, which is associated with complete absence of scalp hair on some part of the body. Usually, it comes in the first year of life, and also associated with some of the white tissue spreading papules on the scalp and some part of our body. The patients also losing the hair follicles as well, and the hair follicles replaced with a cyst. If you put the biopsy from the skin, from the scalp, and you look at the follicle, you're going to see a cyst. We have to mention that alopecia universals is a different disease than Atrichia with papules. Both of them, they are associated with hair loss. However, alopecia universals could be a cause of autoimmune disease as well. So the gene responsible for this disease is called hairless gene, HR, and the protein encoded for this gene called lysine specific demethylase hairless protein. The main function of this protein is histone demethylase, and also there is another function of reversing receptors and nuclear receptor controlling the hair growth. And lately, they found that also affecting the cell proliferation could promote cancer as well. For the case that has been referred to us today, just to look at the variant, is, as I said, it's a patient with Atrichia with papules. It's 1-year-old patient from Irish travelers, and this patient has a father with the same genetic mutation as a homologous allele. And when they look at the variant in this gene, they found this is the variant of this gene. Where the G replaced with A, and the amino acid arginine replaced protein. So to do the interpretation, we're going to follow the process from 1 to 7. First, we're looking at genetic information or overview about the gene itself, and then looking at the disease phenotype and the mutation associated with the disease. Then the protein. Then we'll go for variant alignment. Up to this, we're trying to validate this variant that we do have, and looking at the effect of this variant as a prediction for this variant. Last thing, we're going to classify this variant. First, to go through like having information about the gene, we're going to go to assemble. And when we go to the website, we got a lot of information about the gene. Like the most thing I got, that location of the gene and the transcript, and giving us here details about the gene. It shows me here this gene has 9 transcript and has a 3 protein. Then we look at the disease phenotype. Usually we go to OMM to look at the disease phenotype. And search with the disease itself, as you see here, giving you a number, which we call OMM number, as you see here, and giving you some information about the genetic mutation associated with this disease, and also what is the other disease that associated with our gene target. At the bottom of this table, you're going to see some summary of studies that reported the disease that I was searching for, or for the genetic mutations. Then I'll go to the protein to look at the protein encoded for HR gene. And the first thing, when you search using Uniprot website, you just put the gene itself or the protein. Give you the name of the protein here, lysine specific demethylase, and it has a histone demethylase function. It has a 4 domain as in G1GC, zinc finger, and motif. And you look at the position of the variant that you have, which domain or motif and the protein itself. Also, you can get the sequence of for this protein through going to BLAST and the top here. The other thing I like in the Uniprot, you can go to variant and you look at the whole variant in the protein itself, including our variant of interest here in 620. Then I go to the variant alignment. I use the cluster omega, or you can use Uniprot as well. First, I did 3 species. I saw that arginine is conserved here. When I go to other more for 12 species, I'm using another website as a cluster omega. I saw that 620 has different amino acids. For variant validation, I use the variant validator website, and then also I got the ID number from dbSNP for our variant. For variant validator, I use it to have the genomic coordinate and look at the transcript itself. And for the dbSNP, I just go to have the ID, so it's going to be easier for me to search more about this. To predict the variant effect, I went through 3 tools. First, I go to SEPT. By putting the variant, look at the location of our amino acid. Here is 620 arginine. If it's replaced with glutamine, here a Q, it's predicted to be tolerated. And giving you a score is 0.39, which is below the threshold, and it's predicted as a. Then I go to polyphen 2. Polyphen, again, you put the variant and it gives me that variant is probably damaging the protein, and the site is conserved site. To do another investigation, I'll go to CADP, and this is giving you the first score, which is 23.8 as you see here, and this is most deleterious, is top of 1% of most deleterious variant. So then I go for variant classification. Variant classification is really like when I see the final classification, I went to the clump bar and give me likely benign. See here with the same variant and ID number from OMM. And there are 3 submitted studies for this. For clump bar says that this variant is likely benign and associated with Atrichia or with the location universals. Also, I went to Barsom on another website, and Barsom gave me benign, as you see here, and based on ACMG criteria. And when you go search more in Barsom, you're going to see all the database that reported this variant, like mostly all the databases. And I see here there are 9 databases reported as benign or tolerated, and there is 7 databases reported as deleterious. So we have our final classification as likely benign variant. And the evidence for our final classification is first because this alteration, it's like in position 620, it's not conserved through the species. Also, our variant that we're looking for, it's predictance and SEPT as tolerated variant. There are other studies reported this variant, and they found that this variant as a heterozygous allele in patients, they have the symptoms of ABL. However, this variant autosomal recessive, which have to be homozygous to give the effect of ABL. And other study, they showed that there's no ABL with the patient. They do have homozygous allele for this variant. Other three study, they shows that it's not only this variant arginine 2620 glutamine associated with the ABL. There are 3 variants also associated with ABL. One of them valine to methionine, and another one is glutamic acid to valine, and also cytosine to glycine. Last thing is The fact that the patient's father itself has a homozygous allele for this variant, but the father doesn't have any symptoms of this disease.